Welcome to C++ for Java programmers. I'm Professor Califf. In this video, I want to start talking about classes in C++. In Java, classes are written as a single entity with all of the elements of the class between a pair of curly braces. In C++, it's a little more complicated. We have class declarations, which declare all of the variables and methods for the class, but we don't actually implement most methods inside the class declaration. Instead, we provide function prototypes, and then we write the actual methods outside of the class declaration. The exception to that is with very short functions, basically those that take up one line. Our declaration will typically go into a .h file, and our method implementations will typically go into a .cpp file. So our classes are usually written in a pair of files. One thing to watch out for with our class declaration is that there is a semicolon after the closing curly brace. Since our method implementations aren't in the class declaration, we do have to associate them with the class they belong to. We do that by adding the class name and 2 colons in front of the method name. Note that the scope operator in C++ is : unlike in Java where we use a dot for this. Before we actually start writing a class, I do want to mention the typical C++ terminology for parts of classes and objects. In C++, we refer to those as the members of a class. The instance variables and class variables are typically referred to as data members. And methods are typically known as member functions. Now the terms method, instance variables, and class variables are all standard object-oriented terminology, not something specific to Java. So I'll continue to use them, but you should know what it means if I or others use the C++ terms. I think the best way for me to show you how we write classes and use objects is just to write a simple class and then some code that uses objects of that class. So let's do that. Okay, so I am going to write a simple date class. So opening a date.h file. Although it's not required to use file names based on the name of your class, it is common to do so because it makes it easier to keep your code straight. So I'm going to skip the comments in this particular case. We should have them, but we're just going to save my typing time. So I'm going to make a class date. Now we're going to start with the word class. Note that in C++, we don't worry about anything like public, private. We just have classes. If they're out there and I can see them, I can use them. If I can't see them, I can't use them. Simple as that. Now, we do have inner classes sometimes where we write one class inside another. In that case, they may be private or public or protected. However, as long as we're just writing a class with it's not inside anything else, it is visible if you can see it, and it is not visible if you can't. There is no notion of private or public on a class itself. Okay, so I'm going to have the class. It's going to have curly braces. I'm going to go ahead and put my semicolon, which I mentioned. That's really important. It can create weird errors if we forget it. Okay, one thing that is different about Java versus C++ is Java puts an access modifier on every single item. And if the item doesn't have an access modifier, then it has default access. In C++, the access modifiers are applied to sections. By default, anything in a class is private. That's different. There is no such notion as the default access kind of thing that we have in Java. So by default, things are private. Still a good idea to note private. In general, when we go to organize our classes, you can put your data in one of 2 places, either at the very top of the class or the very bottom of the class. You'll see people do it both ways. I've been in the habit of putting it at the top of my class for a very long time. That's less common these days. You'll more often see people put it at the bottom of the class. But either is fine. Just make sure it's at one end or the other. And of course, if you're working for a company that has an opinion that that's not fine, do it the way they say to do it. Always follow the coding guidelines of your company. I'm making a simple date class, really simple-minded date class. So we're just going to have a month, a day, and a year, all of them integers. Then we're going to get into our public methods. Now you always want to have your public methods first. Typically people put their constructors, then any getters and setters, then your various methods that do stuff, usually the most important ones first, and then below the public methods, you'll have any private helper type methods that you need. If you put your data at the bottom, make sure you have public methods, private methods, if any, and then private data. Of course, protected methods are typically in between the public and private methods when you have them. Okay, so we wanted a constructor. I'm going to go ahead and make a default constructor. I'm going to save that and define that in my .cpp file because it's not going to be just one line. Then I'm going to have a constructor that takes multiple parameters, all the parameters. And in doing this, I'm going to show you one of the ways you can initialize data in C++. So when we're doing constructors, we can write assignment statements in the body of the constructor, just as we do with other things. But we can also do something called an initialization list. And when we use initializers, it's going to look like this, where I've simply put the name of the instance variable and then the value in parentheses. This is useful because it can also be used to initialize instance variables that are objects. So we can actually have something where we're passing multiple parameters. Basically, we're calling the constructor of that member object in the initialization list. So we can have multiple parameters in the parentheses. We can also, this is how you handle initializing parent classes. So calling parent constructors, basically, in C++. We're not going to cover inheritance today. We'll look at that in a later video. So useful for a lot of things. And then since I've already initialized all of my data, I'm just going to have an empty braces for my constructor. So I'm going to go ahead and implement it here because it doesn't do a single thing. No need to postpone it. Then I'm going to write one of the potential setters. Now notice this const. We'll talk about that a little more, but the purpose of it is basically for me to guarantee, hey, this method is not going to make any changes to this object. And of course, being a getter, it certainly shouldn't make any changes to this object. Then I'm going to have a get short date that just produces a string that's the short form of the date. Note that since I'm using a string, really should add my include up here. And then finally, I'm going to go ahead and include a setter to set the day. Note here that just as with Java, we use this to refer to the calling object. So if we need to get at it, we can do that. And of course, that's very useful when I have a parameter that is the same name as my instance variable. This makes sure that we know that this is different. This day is not the same as the day here. Notice, however, that I use new operator. This is how we're going to use pointers to get at the elements of something. Would have this dot day if it were a reference, but this in C++ is a pointer, not a reference. So I'm going to use this, and then that's just hyphen greater than, which is intended to represent an arrow, and day. And what that does is it both dereferences this pointer and does the dot operator to get at the element, get at the member of this object. So this is our .h file. Let's now create the .cpp file to implement our two methods that we haven't implemented yet. So go ahead and create, let's go ahead and save as. So get that named. That's going to be date.cpp. And at the top of date.cpp, we're always going to have an include. Now, one thing to note is that when we're including our own .h files, we're going to be using quotation marks, not angle brackets. The quotation marks tell the precompiler, which does the include part, that it should start looking in the current directory, searching for the thing that it's trying to find. The angle brackets tell it to go to the C++ library directories, so it doesn't actually look for those items in the local directory. Okay, I'm going to actually skip the using namespace standard this time and show you how we would use things that belong to standard if we don't have that using. So, well, actually, technically, we already have it because it was in date.h. We also don't have to include string.h because it's not there. So actually, if I'm going to do this, I'm going to go remove it here, in which case I'm going to have to add, the way we handle this is again the scope operator, 2 colons, and we just put the namespace : in front of the name that we want to use. So we'll also do that over here in date.cpp. So first let's write the default constructor. So that's going to be just date : date. So this first date : is necessary to tell us that this method that we're writing belongs to the date class. And of course we have no return type because this is a constructor. Now here I'm just going to demonstrate that we can do assignments in our constructors just like we do in Java. So this would be an example. This is setting it, of course, to January 1st, 2020. Why we want to make that our default date, given how 2020 is turning out, not quite sure, but that's what we're going to do. Okay. Let's go ahead and write that get short date. So that returns a string. So to use the string, we're going to need the std : in front of it. Then I need the class name to identify that this get short date belongs to the class. Then I need the const again. So over in date.h, we have const here. We also need it here. If we don't have it here, then it'll actually complain that we haven't implemented the one with const, and could complain that it doesn't have a declaration for the one without const. Now note the class name : goes right on the method name, whether you've got a return type or not. Okay, and to do this, I'm going to simply build the string and return it directly. It turns out that the string provides the string library, including the class. We get a toString method that will take an integer and return the corresponding string. And we have that for a variety of different types, actually. So to call that, I would do standard, because this toString is in the standard namespace, : to underscore string, and then the integer, in this case month. I'm doing standard American dates plus standard toString day plus another slash plus standard toString year. Okay. And there we have actually implemented our two methods. So now we need to actually have a program to use them. So let's go ahead and create one more file. And this is normal. We would typically have a file for our .h file with our class declaration, a file for our method implementations, and then a separate CPP file for our program. And of course, sometimes we'll have many classes, each of which will have two files, and then a file for our program. Okay, so let's go ahead and call this program just date experiments.cpp. And here we once again need to include date.h, because unless we do that, we can't actually use the date class. Then I'm going to include IOStream, because I want to do some input and output, well, some output, so that we can see what we're doing. And then I'm going to go ahead and use the namespace standard here. So let's create a main. And then the first date that I'm going to create is just a default date. Now notice something funky here. It looks like I've just declared a date. So you may think, okay, so she's going to make a date later. Actually, right there, I've made a date, because objects can just live on the stack. And when we use the default constructor, we actually do not use parentheses in C++. Because if I did this, C++ would think that I was declaring a function that returned a date. So I can actually declare functions pretty much anywhere. The correct syntax for I'm creating a date, just local variable, no references or pointers involved, using the default constructor, is exactly this. Now, if I want to create another date, so let's do that. I'm going to call this school start 8/17/2020, because that's when my semester started. Now here, we've done pretty much the same thing, but we're actually calling a constructor that takes arguments. So we do include the parentheses when we have arguments to pass. So now let's print those out. Default date dot get short date, and a new line, and cout school start dot get short date, and a new line. And then I want to actually modify the default date. So I'm going to set its day to 20. Any value will do. And go ahead and print the result of that change. Okay, so we've written a fair bit of code. Usually not a good idea to write this much code and then compile it, but fortunately it was fairly simple code. So let's see how we go about compiling that. So if we're compiling a program with multiple .cpp files, what we're going to do is G++, and then we have to include all of the files in the program in our compilation command. So here we'll have date.cpp. We don't compile the .h file. The .h file got copied into our .cpp files. We only compile the .cpp files, but we compile all of them. So we have G++ date.cpp space date experiments.cpp. And amazingly enough, we didn't make any syntax errors. So now let's try running that. So /a.out. And it worked. So default date, short, printed out 1/1/2020. The school start printed out 8/17/2020. And then our modifications printed out the 1/20 after we changed the date to 20. So now before we go back to talk about a few details, I do want to show you a few other things. So first of all, I want to demonstrate that we could do the date somewhat differently. And there are a couple of different ways we could do the date, the default date. So one option would be to directly create an initialization list here that took the values. So we would do something just like we did down below and just pass in the values directly instead. So let's actually see what happens if I do that, make sure that worked correctly. Do have to end that with a set of curly braces. So let's make sure we save that. Come back over here. Not sure if I saved everything. Let's see if everything's saved. Ah, yes, I hadn't saved the date.cpp, so we were getting a double definition of the date constructor, that default constructor, because I hadn't actually saved it after I commented it out. So let's make sure that still works the same. And in fact, it does. Then there's one other way we could do this. So I've already defined something that takes in all of these things. So I can actually do this similarly to how we might do it in Java, really, if we were calling this and something. So here we call date and then pass it the values that we're interested in. And you can see that that works as well. So what we've done here is very similar to in Java. If we, in the first line of our constructor, we had this and then the arguments that we wanted, so that we were calling the one that took multiple arguments. We could in fact do that. Of course, yet another way to do it would be to set up default arguments. Okay, one other thing I want to look at is what if we create these objects dynamically? So I'm going to actually make this a pointer and then say new date. And then here we'll make this a pointer as well. So then in that case, of course, we will have the parentheses and the arguments. then one other thing will change here. In fact, let's go see what the error is that we get if we don't make the other change. So what it's going to say is that it's requesting a member in default date, which is of pointer type date star and doesn't have any. So what we have to do here is to change our dots to this arrow notation that we used with this as well. So let's fix all of those. And make sure we've saved. What did I do? Ah, typos, always deadly. And you can see that this all works fine. So I do want to show you what the error looks like if you do the date with, try to declare a date object with the default constructor, but have this instead. That's actually only going to impact, so apparently you are allowed to have the parentheses on the new, on the pointer version. So if you're actually using new, but you're really not allowed to have them here. So let's see what that error looks like. And we'll see request for member get short date in default date, which is of non-class time date parentheses, which basically means it's a function. So as long as you do that, then it's just not going to work. So no parentheses. Okay, let's go back to our slides. Okay, we talked a little bit about this, but I do want to re-emphasize const on methods. So this is our third use of that keyword const. And it's declaring that the method won't change the object. You need it if you've passed an object as a const parameter, which does happen, not infrequently. In that case, we have to make sure we have the version of the method that won't change the object. Generally speaking, any getter you write should be const. Obviously, constructors and setters won't be. But then look at all the rest of your methods and say, does this change the object or not? If it doesn't, make it const. Okay, I want to talk to you just a little bit about this whole notion of the inline function. So these functions that we actually implement in the class declaration are called inline functions. And the idea here is that they're similar to a macro, but safer. So C and still C++ has these things called macros that you create using define that just do text copies of the code into the place where things are. So that can be useful, but it can also be very dangerous. It can create weird errors at times. So inline functions do something very similar. They replace the function call with machine code that's going to do the work right there without making the call. But you have the function which provides certain protections and so forth. So for very short functions, this is more efficient. For longer functions, it's generally less efficient. So for the most part, if you've got a line, maybe 2 lines in your function, it's not doing a whole lot. Now by this, I do not mean lots of function calls. Even though get short date is only 1 statement long, it's calling 3 other functions, it's doing a bunch of work. So we probably wouldn't ever want to inline that. But any getter that's not doing a lot of processing probably should be inlined. Same thing for setters. Now, if they're doing a fair bit of processing, they should not be inlined. If they're doing very little processing, you can make your code more efficient by defining them in the class declaration. Note that you can actually implement them outside the declaration with an inline keyword, though you'll very rarely see that done. Now, I do want to talk some about this operator. We've seen it, but just want to explain a little bit more about it. So when I reference a part of an object that I have a pointer to, I'm going to use that arrow operator. And here would be an example. Got a pointer to a student, calling the getMajor method. I'm going to use that arrow operator. The reason we need this is that the dot operator has higher precedence than the dereference operator. So if we do star stuPointer.getMajor, we're going to get an error. We can use that. We can use the dot operator if we put the dereference in parentheses. But this gets kind of unwieldy. So you've got this arrow operator available as an alternative, which everyone uses, because nobody wants to type parenthesis star the thing close parenthesis dot instead of just the thing hyphen greater than. This is useful for making sure you understand what this is doing, but use this. Get yourself to figure it out, learn it. Once you get comfortable with what it means, you will like it better. I want to mention class variables and methods. So this works a lot like it does in Java in a lot of ways. It uses the static keyword just the same as Java does. And for methods, it's the same. Class variables, on the other hand, are declared similarly, but they have to also be defined outside the class. In general, you need to do that in the .cpp file for the class, because you don't want to make copies of this declaration. So let's actually come over here. First, I want to just show you the error that you're going to get if you actually do. So school start is still a pointer, so I'm going to actually modify this so that I'm trying to do the dereference dot thing. So let's try to compile that, and we're going to get what does it not like about data.cpp? Expected initialization. Oh, I'd taken out the semicolon and I never put it back in. So let's put that semicolon back in and just get the error that we're interested in, which is error request for member get short date in school start, which is of pointer type date star. Maybe you meant to use the arrow operator. So very smart compilers these days. Be grateful for them. But you will, as you can see, get an error. Now, I will actually demonstrate that if I add the parentheses, this will actually work. But I hope that you can see that this is terribly unwieldy, and it's much better to go ahead and just use the arrow operator. Okay, so static. I'm going to add a static int count. Actually, we'll make it date counter. Now, this is a common thing to do for certain kinds of objects, to keep track of how many objects you have. Not so common for something like a date, but we can do it. So now let's have int get static int get num dates, and we'll just return date counter. Now, so far, this looks pretty familiar, but if we try to use it, it's not going to work well. Let's add something right here that actually uses it. So, cout. Now, how we call statics is we're going to use the class name, just like we do in Java, but we're going to need the : operator to do it. So it's going to be date : get, what did I call it? Get num dates. Okay, now if I try to compile this, it should not work because I have this problem that I've got an undefined reference to date counter. So what I need here is to actually define some space for this integer and give it an initial value. So the way I'm going to do that is over here in the .cpp file, I'm going to say int date : it's called date counter, right? Date counter is assigned 0. Now, let's see what happens here. Helps if I have the ER on it. And that then is going to work. And let's try actually running it. And we haven't actually changed it, so let's actually add some code to use it. So what I'm going to do here is to actually say date counter ++ in this constructor, and also say date counter ++ in this constructor. Recompile that and do a.out. Now that, oh, I don't actually want to add one here because I've double counted any default ones. Okay, so you have to be careful about things like that. If I'm calling that other constructor, don't do something in this one too that you only want to do in the constructor. So that's just a little bit of how you actually work with statics. As you can see, the static method very much like Java. The biggest difference is that we use the : operator rather than the dot to call things. Okay. Now I want to end by talking a little bit about the notion of separate compilation, because you may be wondering why we actually are writing our code in multiple files and why we separate the pieces of the classes the way we do it. So the name for that is separate compilation, and we do have a few reasons. So first of all, it can help us more easily reuse the same code in multiple programs. I'm not extracting a piece of a file to use, just more prone to error than taking a whole file. Of course, this part of separate compilation, Java also does. Each class is in its own file. Note that in C++, this concept actually applies to more than just classes. We also have libraries that are written in a .h file and a corresponding CPP file without a class in sight. In C++, remember we have to see declarations for everything we want to see earlier in the same file. If we didn't break our libraries and classes up into a .h file and a .cpp file, and we just included the .cpp files, we run the risk of including the same code twice, which is a compile time error. Now that may sound a little far-fetched, but consider this scenario. Suppose I am just using CPP files, And I have a student class and a faculty class that both inherit from a person class. So my program file is going to include student.cpp and faculty.cpp. So far, so good. But each of them includes the person.cpp. And right here, we have an error if there are any actual implementations of methods or declarations of static variables in person.cpp. The final reason we do separate compilation the way we do it in C++ has to do with efficiency. Compilation of C++ programs goes through multiple steps. So take a look at it in this diagram. So assume we have several .cpp files and their corresponding .h files. So first we run through a pre-compiler, and that is going to execute various pre-compiler commands, including the include, which simply is going to copy any .h files that we've included, including the ones that belong to the C++ or C libraries that we're using, and produces an expanded .cpp file in each case. Now, we usually don't see that, but we can actually use appropriate arguments to our compiler command and get it to show us this file. Then the next step, which we also sometimes don't see, certainly don't see in the cases where we've just been compiling everything all at once, we actually go through the compiler, and that's going to take the .cpp file, this expanded .cpp file, and produce what we call an object file, which is in binary. It's machine code, but it doesn't have all the information, all the connections necessary to be an executable program. And each chunk is separate from all the other chunks at this point. And there are also chunks out where we don't usually see them of the object files for the various libraries that we might be using, like iostream or string. So then we take the program through what's called a linker, and that pulls in all of the different object files, both ours and the ones that belong to the C++ libraries, and it turns them into an executable program. Now, for a 3-file program, it really doesn't matter that much that you're doing it right. But if you have a very, very large program, it can matter a great deal. So I had an acquaintance at one point several years ago who was working on a large console game, and it was being done in C++, dozens of classes, lots of time to build it. So to compile all of the files took about an hour, and to link the resulting object files together took more like 10 minutes. So if every time he made a change he had to compile everything, you're losing an hour of productivity every single time you actually test to see if your stuff compiles correctly. However, because it was done right, because it was broken up, if he made changes just to a .cpp file, he would only have to compile that .cpp file. All of the other object files could stay just the way they are. He still had to go through that 10-minute linking process, but that was way better than spending a whole hour building everything from scratch. When you make changes to a .h file, then you're going to have to compile more files. In this particular case, we'd have to compile both class 1 and program, but class 2 wouldn't be touched. And so we would at least avoid compiling that one. And so that's the notion behind separate compilation. Now, in order to do that, you're not going to do compilation the way we're doing it, where we just compile all the files together all at once. And in a later video, I will talk about how we handle that situation in Linux in a command line environment like this, which is something called a makefile. Now, if you're working in an integrated development environment, that integrated development environment, if you set up your code correctly, it will handle all of the doing separate compilation and so forth for you just great. I've covered quite a bit about classes. I know we've got other things to cover, but we'll come back to inheritance later. In the next video, we'll talk about overloading operators in C++. And then in the video after that, we'll be focused on how we handle the dynamic memory management piece in C++ classes. Thanks for watching. I'll see you next time.